this is the question of 2007 October November paper 1. There is no variant here because they didn't have it at that time, and the question number is 35. So we have 4 identical resistors here. So these are the identical resistors. Let us write them as R. Here also all of them are. In diagram 1, the ammeter reads 1 ampere, so this current is 1 ampere, and the voltmeter reads 0. So this is 1 ampere, and the voltmeter reads 0. So this thing is PD is equal to 0 volt. The resistors and meters are reconnected to the supply as shown in figure diagram 2, as in the diagram. So we have to find what are the meter readings in diagram 2. So here what we need to know is, since all of these things are identical, what we have here is from here to here it is 6 volt as given here. So from here to here it is 3 volt here, and it's also 3 volt here, and from here to here it is 3 volt we have, and from here to here, so let's write it here, from here to here it is again 3 volt, and the current here is 1 ampere. So here we have a 1 ampere current. Since these two resistors are identical, the current here should also be 1 ampere. Now since this point and this point have equal PD with this point, so it has got PD 3 volt at this point, it has got PD 3 volt at this point. So here there should be no current, and there should be 0 volt as well, as given in the question. So that means here also it should be 1 ampere, and here also it should be 1 ampere. Now here things have changed, so we have changed everything. The whole setup has been changed, and now the circuit reads somewhat like this. So let us redraw this circuit. If redrawn, the circle will appear as, so let me draw first this here, negative, positive, negative, positive, like this. So from here let me draw this thing. So this is somewhat like this. This is R, and this is again R, like this, and again if I draw this here, whether this side or this side, it is same, because the PD across this thing is equal to this EMF. So I can draw it like this. So this is R, and this is again R. So it is R, and R. And now we have to connect this point, which is the midpoint of this thing, with this point, which is the midpoint of this thing. So that means the voltmeter connects here. So this is the voltmeter V, which is here. So this is another arrangement of this thing. So since this is a 6.0 volt, it has got 2 branches here, R and R, and here as it is shown here, the ammeter is here. So we have to show the ammeter somewhere here. So it should be somewhere here. It comes from cell this to this arrangement. So ammeter should be somewhere around here. So this is the ammeter. So let us say here, this is the ammeter. Now we have to find the current in the ammeter as well. So since the from the potential divider theorem, what you can say is the PD here is 6/2, which is 3 volt, and here also it is 3 volt. Here it is 3 volt, and here also it is 3 volt. So that means there is no PD here, no PD between this and this. So that's why V should be equal to 0 volt, So V 0 volt, if we go through the choices, it is in choice number A, and no other choices have got 0 volt. So it seems that the choice number A is the correct answer. So to confirm it further, let's go for the current. So since we have the 6 volt here, the current from here should divide. So the whole combination is 4R here. The resistor combination is 4R. So here also it was 4R. So that's why the current through the cell here and through the cell here should be same. The current here is 1 ampere, 1 ampere, 2 ampere. So this current is 2 ampere. So that means the current here also should be 2 ampere. Now this current should divide equally here because the branches have got equal resistor. So that means it should be 1 ampere here and it should be 1 ampere here in this branch as well. So that's why the ammeter reading should be 1 ampere, which is in choice number A. So actually we did not need to find this thing because the voltmeter reading was already 0 as given previously. So but still we did this to confirm that this is the most correct answer.